Okay. So this is, you can term that this measures how much variability is there into the height. Means how much all these data sets are deviated away from the mean. Now, there is one more term, and that term is named as covariance. Now, what is covariance? So, variance actually measure the variability in a single data. Say, suppose you have got x1, yeah, x is height, and another variable y, it is weight. Now you want to measure the joint variability of this x and y. So it will be measured in terms of covariance. So for x1, you will have again height, you will again have x1, x2, x100. So 100 values will be for height. Similarly, y1, y2, y100. 100 values will be for y. Okay. So what will be the covariance? Covariance will be nothing. Here what you did, xi minus x bar again into xi minus x bar. Here what you have to do, xi x1 minus x bar into y1 minus y bar, x2 minus x bar into y2 minus y bar. Similarly, हाँ धर्मेंद्र बताए, ठीक ठीक. Similarly, x100 minus x bar into y100 minus y bar. And then again, just multiplying it and summing it. So it will be 1 upon n summation xi minus x bar and yi minus y bar. So what we are doing in variance, xi minus x bar into xi minus x bar. And what we are doing in covariance, so it is termed as covariance between x and y. It is xi minus x bar into yi minus y bar divided by 1 by n. So it gives you an idea what is the joint variability of two variable in the data. Okay. So once you have got it, so now I will be discussing one more term. What is this variance covariance matrix? Okay. So this variance covariance matrix is nothing but, say in a data set, because factor analysis is dealing with the p dimensional data set. P means it can be 10, it can be 15. So let us, we have a p dimensional data set. So what is the meaning of this p dimensional data set? That you have got x1, x2, x3, x4, x5. Okay. So there are, you can say again 100 students. And this x1 is marks of math, science, social studies, Hindi, and English. Okay. These are the marks of these 100 students. Okay. So this x1, so mark all the first student mathematics marks 60, 80, like this. 72 science marks 72, 99, 84. Okay. And similarly, the marks in social studies 54, 62, 81, 92, 91, 89, like this. The marks in this 82, 63, and 91. So you can see that this is a data set. Okay. This is a data set. So now what I'm trying to say that this data set X is like this, and I will be writing it that it is composed of 5 variable I discussed in the previous slide. This is composed of 5 variable where X1, X2, X3, X4, X2, mathematics marks, science marks, social studies marks, Hindi's marks. So what then again? What is the mean vector mean of all these? So if you'll take the mean of mathematics marks here, add all these and divide it by 100. So it will be represented by mu1, mu2, mu3, mu4 and mu5. So average here you will get mu1, here you will get mu2, here you will get mu3, mu4 and mu5. So it can be summarized like this: mean vector mu, and we have now variance covariance matrix. So now what is this variance covariance matrix? So as I told you that this x1, so there will be the variance of x1, so it will be represented by sigma 1, 1. There will be the variance of x2, okay, so it will be represented by sigma 1, 2. Similarly, variance of x3, it will be represented by sigma 1, 3. So all these have got variance. I will share the PPT when the session will be over, because I'm writing in this PPT. Okay, so don't worry about that. Now, what is variance covariance matrix? So I am writing it down. It is represented by this, and here it will be sigma 1, 1. Now, what is sigma 1, 2? Sigma 1, 2 is the covariance between x1 and x2. What is sigma 1, 3? Sigma 1, 3 the covariance between x1 and x3. Similarly, sigma 1, 4, sigma 1, 5. Then sigma 2, 1, sigma 2, 2, sigma 2, 3, sigma 2, 4, sigma 2, 5. And similarly, if you write on sigma 5, 1, sigma 5, 2, sigma 5, 3, sigma 5, 4, and sigma 5, 5. So you can see in the diagonal, we have got the variance component, and in the off diagonal, we have got covariance component. So this variance, this is termed as variance covariance matrix. Okay. Now, why I am telling? Because factor analysis is going to depend upon this variance covariance matrix a lot. So you should have an idea that what actually variance covariance matrix is. So variance, it measures the variability in a variable. Covariance measures the variability between two variables. For example, this sigma 1, 2, it measures the joint variability of x1 and x2. Sigma 5, 2, it measures the joint variability of x5 and x2. Okay, so this is termed as covariance between x5 and x2. Now, with these notation, with these concept, now I'm moving to this term. What is the factor analysis? So let us say that there is a factor. There is a, or you can say, latent variable, or you can say UNOBSERVA, unobservable quantity. Okay, say there is a person have the nature of taking risk in his life. He is a risk taking in nature. Okay, so this is actually the factor which is not directly observable, but because of this factor, there will be something which will be the manifest, which is observable because of this factor. What is that he might be rule breaker, Okay, he might be fined. So because he is risk taking, and he might be taking a loan, lot of loan, because he is going to take the risk into the market. So this risk taking behavior is there, and there, because of this, we have got some manifest variable. And this variable will be observable. This variable is the observable variable. Now, since these variable observe, so with the help of this variable, with the help of factor analysis, can we measure the hidden factor? So that is the idea behind doing the factor analysis. That, for example, in the previous example I was discussing, that you can see that there are 5 subjects. Okay, there are 5 subjects. So a student, usually you people might have observed a student who is very good at his mathematical and science. That student may not be as good as in Hindi and English and or social studies. Okay, so student, he may be uh, because of his hidden factor. Okay, so there are you can say uh, you can say that there are hidden factor of the student. Student can be of there are the factor or the latent or unobserved quantity, whether the student is of numerical ability, and another hidden factor is, you can say, numerical ability. Other hidden factor is literature ability. You want to measure this numerical ability and literature ability of the student. So this is not directly observable. So, but because of these hidden factors, the marks of the student, which are observable variable, है ना? These are observable variable. Marks in mathematics, marks in science, marks in social studies, marks in Hindi, and marks in Hindi. And there may be another some more marks also. So because of these hidden factor, it will manifest into observable variable. Okay, so those x1, x2, x3, x5, those are observable variable. Now, can these observable variable, how can these observable variable will be used to measure the hidden factor? So that is done with the help of factor analysis. So this is the you can say diagrammatic idea behind doing the factor analysis. Okay, now as I told that if
Dr. Anoop, Dr. Anoop, there is no audio. Hello. Dr. Anoop, the participants, please wait. We are correcting this technical issues.
Hello. ये
हाँ, अब हो गया सर, हो गया, हो गया। थैंक यू सर, हो गया, अब हो गया।
ठीक।
Hello. So I think now it is okay. I'm audible.
Yes.
Yes, sir.
Okay.
जी सर
Okay.
सुन पा रहे हैं।
what I'm saying that somebody is on mute. They have to mute somebody's. Okay. So now what I'm saying that this x1,
सर प्लीज सर
yes,
सर
yes.
एडमिन से रिक्वेस्ट है सर कि बाकी लोग को म्यूट कर दें.
Now this is a very important concept because what I'm saying that again there are x1, x2 and xp observable variables. Okay. And yes,
Dr.
yes.
Please ask the audience participants to mute themselves because they are disturbing. Audience, please mute yourself. Participants, please mute yourself.
Tejas Jayasankar is speaking. It's coming from some Tejas. So whoever the host is, he can. Yeah. Now it's okay. So now what I was saying that x1, x2, and xp, these are the p observable quantity, and f1, f2, fm, these are unobservable factors. So now this f1 is contributing to something to this x1, f2 is also contributing, and similarly fm is also contributing. So what I'm saying, it is contributing lambda 11, lambda 12, and lambda 1m. So now I'm writing it like this. x1, it can be how mathematically I am trying to make a relationship between observable x1 and unobservable factors. It can be written as mu1 plus factor loading due to factor 1, factor loading on 1 due to factor 2, and similarly factor loading on 1 due to factor m. But still there will be something which cannot be contributed by all these factors, so that will go into the error term, and that is represented by delta 1. So what is saying that still this x1 delta 1 part is something which cannot be measured by all these factors. Okay. So again, these x1, x2 are the marks of the student, and this f1, f2, fm are the ability of the student, mathematical ability or his analytical ability, like this. So these are unobservable. What I did, marks of the mathematics, how much this ability is contributing in getting marks in mathematics, how much another ability is contributing getting marks in mathematics, like this. So this is what a mathematical equation is. Similarly, for x2, we can write down mu2 plus, now how much f1 is contributing to x2, how much f2 is contributing to x, and how much fm is the mth unobservable. So it will be represented by lambda 21, lambda 22, and lambda 2m. So it was the lambda 21 f1 plus lambda 22 f2 plus lambda 2m fm plus the error term delta 2. And again, if I will write it down for last, so it can be mean vector mu p, mean of mu p plus lambda p1 f1, means how much f1 is contributing. Mu is the mean vector, mean of xpth observation, means mean of mathematics marks. mean of physics mass. These are the mean for first variable. This is mean of pth variable, like this. And then lambda P2 F2, contribution of second factor on the pth, like this. Lambda PM FM plus delta P. So this is how the relationship between observable and unobservable quantities are being established. To write it down in terms of matrix notation, to simplify it, I will be writing it log down. There are P observable quantities, and it is written at like this: mean vector of all these observable quantities plus factor loadings. These are the factor loadings. Multiplied by factors F1, F2, Fm plus the error term. So plus the error term, and that is delta 1, delta 2, delta m. And to further summarize it, this is written as x is equal to mean vector mu plus factor loading matrix lambda plus latent variable factors this, and so this can be written as x minus mu, which is equal to, now this actually is termed as factor model. This is termed as factor model. Now you can see that how beautifully with the if you people not have, I thought you people might have gone through the regression yesterday, but this is actually the regression equation between the observable quantity, and in unobservable quantity. So this is a this model is termed as factor model. Okay. So now, what is very important for all of us to understand at this particular point of time is now that how these factor which I was discussing right now, that it is termed as exploratory, EXPLORAT, exploratory factor analysis. Because with the help of this model, x1, x2, xp, I am saying, I am exploring that what are the hidden factors. I am exploring
So audio video both has stopped. Has it stopped for others?
Yes.
Yes, and then stuck.
Yes, it is for us.
Yes, sir. It's like paused. Maybe some net issue. I don't know.
Dr. Anup? Dr. Anup, can you hear me?
Admin can tell us what has happened.
We are trying. There is some technical issue. We are sorting this one. Please wait. Please wait.
Okay, thank you, sir.
Dr. Anup, can you hear me? Dr. Anup, are you there? Dr. Anup, are you there?
Yes, I'm there, sir. Kindly allow me to share the screen.
Yeah, your screen is visible.
No. I don't know why it is happening again and again. Okay, now,
Yeah.
actually, I was discussing about exploratory factor analysis and confirmatory factor analysis. So in exploratory factor analysis, we don't know how many factors, hidden factors are there. We are exploring them. But in confirmatory factor analysis, the PI or the evaluator already know how many factors are there. So today we will be focusing upon this exploratory factor analysis. That is what I have discussed. Okay. So this exploratory factor analysis, it is also termed as orthogonal factor analysis, because in this case we say that this F1, F2, Fm, they are independent.
Sir, this slide we missed due to connectivity issue. Can you repeat, please?
Yes, I can repeat, no problem. So I think this factor model I've explained.
Yes, this part is
Excellent, sir.
clear.
Excellent.
Completed.
Next one.
Yes,
Of
yes.
the slide which has exploratory and confirmatory, you were started with the exploratory part. The confirmatory part was not done.
Okay, so I will be just repeating
Right.
that slide again. Okay.
Right.
So this model is termed as factor model because it establishes a relationship between observable quantity and this unobservable quantity. Okay, now the software, or there are various techniques to solve this equation in statistics. So that will go very mathematical. So I will not go into that. but at least you should know that how this relationship is being established. Okay. Now, what is exploratory factor analysis? We have got some observed x1, x2, xp, and with the help of this, I don't know how many unobservable quantities are there. I am exploring the unobservable quantities. So this is termed as exploratory factor analysis. One of the very important assumption in this exploratory factor analysis is that all these unobservable factors are independent. They are not, there is no relationship between these f1 and f2. They are independent. For example, the mathematical ability and the literature ability of the student, these two are independent trait of the student. Okay, if such things are there, then we are saying that this is the exploratory factor analysis. But if there is a relationship between these factors, if they are not independent, if they are dependent, then the factor analysis is termed as oblique, oblique oblique factor analysis. When there is a relationship between these factors, then we say that this is oblique factor analysis. Sometimes the PIs know that factors are there and factors are also related to each other. So such if we'll proceed with such assumption, then it is termed as oblique factor analysis. What is confirmatory factor analysis? Before conducting the factor analysis, PI knows that I have got only 3 factors. I have only 3 hidden factors, and you have to search that which variables are associated with these 3 factors. Just if this analysis, if you are going to do, so this is confirmatory factor analysis, and the advanced version of this confirmatory analysis is also termed as path analysis and is SCM. Okay, so that is I'm not going to discuss today. I will be discussing only on this exploratory factor analysis. Okay, so there are certain assumptions and notations for this, and the assumptions which are there, that is quite obvious. One assumption is that the mean vector, the mean of this, it will be represented by mean vector mu. The variance covariance of x it is represented by sigma variance covariance matrix. Another thing is very important, that this on an average, the mean of these factors, if you'll measure, it will be 0. Expected value of the error term is also 0, and the covariance of this is a identity matrix, means they are independent, and the covariance of the error term, it will be represented by psi, and covariance between the factor and the error term, it will be 0. So these are the notations and assumption of the factor model. That is not very much, but I discussed orthogonal and oblique factor analysis already. Now, what actually is being very much important for all of us to understand at this particular point of time is that this as I've already written, that this x minus mu, it is equal to so this is our factor loading And now if I want to convert it in the form of sigma. Now this sigma is expected value of x minus mu and x minus mu transpose. This is the formula of sigma. So this sigma, if I will write it down here like this, so it will be nothing but expected value of x minus mu transpose. And if I will put this value, it means delta so I've substituted and after some steps, it will come out something like this. Okay, so this is actually we use principal component method analysis to solve this equation. Okay, now what actually is happening is that in such situation we are simply क्या हो गया? P is transpose in the notation. Now this is actually written in terms of these factor loadings and the error term. Okay, so what does I mean to say with this is that this sigma 11 is associated with this factor over here and with this factor over here. Okay, so what does it mean? That this if I'm saying that the factor jth variable is there, so it is measured in terms of sigma jj, and it can be, we can say, broken into two parts. One part which is explained by the factors and another part which is unexplained. So this part which is explained by the factor, it is termed as communalities, and this part which is not explained, it is termed as unique or specific variability, which is not explained by the factors. Okay, so how these communities are being captured through the data analysis, that part also I'll be explaining to you in the practical example. So what actually up to now I have discussed is that you have got some observable variables, and with the help of these unobservable variables, you are trying to quantify, you are trying to measure these unobservable quantities, and you have said that these are the factor loadings. This lambda 11, as I told you, contribution of factor 1 on x1, contribution of factor 2 on x1, and the contribution of factors, these are represented by these and similarly lambda p1, lambda p2, and lambda. Okay, now If you will square all these and sum over here, so it will be represented by H1 square, that is communities, H1 square, H2 square, and HP square. Okay. And here downside, if I will say that it is Q1, Q2, and QM, these are termed as eigenvalues. Okay. In principal component analysis, we'll use this eigenvalues method to find out these lambda 11, lambda 12, and lambda 1p. Okay. So with these notations, with this introduction, now what I would like to say that this factor analysis quantifies those construct with the help of the observable manifest variable. Now, why this is being very much important? Why this is the lesser the information content, the better the design. Okay, means there are P observable quantity and you are converting it into M unobservable quantity. So the lesser the information content, the better the design. For example, there is a remote or there is a TV remote, and in the TV remote there are lots of buttons. Okay, lots of information are there. So that will lead you to a bit more confusion. And there is 1, 2, 3, lots of button, and then in center, volume up, volume down, lot of informations are there. What this is trying to convert it into a smaller dimensional remote, in which there is one by which you can increase or decrease the volume. There is one by which you can change the channel, and there is one by which you can on and off the TV channel, and there is one more button by which you can move to various portals of the channel. So the lesser the information content, the better the design. For this also, this factor analysis is very much important. So factor analysis also it used for dimension reduction. Okay, and the very important thing is that one more definition for factor analysis is that the purpose of factor analysis is to describe, if possible, the covariance relationship among many observable variable into few unobservable underlying random quantities called factor. So now what I was discussing, if you people might go through these definitions of factor analysis, so you will able to understand. So what actually factor analysis do? Factor analysis tries to quantify hidden variables, and because of this, it is also used for dimension reduction. Okay. Now, as I told you that we have got this equation. So this is our variance covariance matrix. So this is also observable. And this delta transpose, this is factor loadings matrix. And this is unobservable. Now, with the help of these methods, factor component analysis, principal factor method, and maximum likelihood method, we can estimate these factor loadings. Okay. But this is how we can do that. This is out of scope of this lecture. the software will do this for us. I will explain how the software is going to estimate our factor loadings. Now, the very important thing is that how we can think that whether these observable quantities is good for factor analysis. Okay, so first important thing, you can create a correlation matrix. Okay, if you will observe, so now just find out the correlation matrix. Okay, and see that if all the observations in the correlation matrix, if maximum of them are more than 0.30, then you can think of that this is good for factor analysis. Okay, because this sigma 11, sigma 22, and sigma pp, this is the variance of this, but this sigma 12 means the correlation between sigma and sigma 12, it should be more than 0.30. Sigma 13, it should be more than 0.30. If you observe that all these quantities are more than 0.30, so this is a good means this x1, x2, and xp, this is a good data for doing the factor analysis. So this is the first observation by which you can go for this factor analysis. Second test which usually you can do is the Barlest sphericity test. In this, we assume that our this correlation matrix is identity. What does it mean? It means that this is a 1, 1, 1. This our variance covariance matrix sigma. It is 1, 1, 1, 1, and offside is very much close to 0. So the null hypothesis is saying that this is I, identity matrix I, and alternative hypothesis saying that this is not equal to I. Okay, so this we test this, and with the help of chi-square statistics, we can say whether we should proceed for factor analysis or not. Third one is this KMO test, and this test actually also measures the sampling adequacy, and they propose that if this KMO test is more than 0.9, so this is marvelous for doing the factor analysis, and if it is 0.80, it is meritorious. 7 points if it is middling, and in the 60 it is mediocre, and if it is 50 or less than 50, then we should not go for doing the factor analysis. So before proceeding or doing the factor analysis, we should observe all these quantities too. Okay, now another very important thing, which is how many factors in exploratory factor analysis, how many factors we should retain, how to decide that. Okay, so there is one criteria which is termed as eigenvalues criteria, and in this eigenvalue criteria, just it is if the eigenvalues, all the eigenvalues which are more than 1, that should be taken into consideration. Another criteria is the percentage cumulative explained. Okay, means how much percentage of variability is being explained by this. And third criteria is the screen plot or elbow criteria. Okay, so by these 3 techniques, we can decide that out of m factors, how many factors we should discuss. Okay, now let us take an example. So this example is actually taken from Johnson and Witchen book. So in this example, we have got we have got 6 marks of 6 subjects, And what are those 6 subjects? Is Gaelic, English, history, arithmetic, algebra, and geometry. Okay, so these are the 6 subjects, and this is our this rank correlation matrix. Okay, so what actually this rank correlation matrix is something, why this is not written in the downside, because this sigma 1 1 is equal to, sigma 2 1 is equal to sigma 1 2. That's why whatever value 4.439, it is again here 0.439 can be written. Now the question is that you can see that by this, that most of the observations are more than 0.3. Okay, most of these values are more than 0.3. So few of them are not, but still this is not, but most of them are more than 0.3. So this is a good data by which we can proceed for factor analysis. But if all these observations are very much close to 0, or if all these observations are less than 0.3, then we should not proceed for doing factor analysis. Okay, so now we just did the things on the software, and we find out this factor loadings that I told you, that this lambda 1 1, you can see that this lambda 1 1, what is this f1 f2, there are 2 factors, and how much this is contributing to Gaelic. So this is 0.533. So this is nothing but this is lambda 1 1. Okay, how much factor 1 is contributing to Gaelic, and how much factor 2 is contributing to, so this is lambda 1 2. So this is what is being estimated. That is what I was discussing. Okay, now what is the importance? And these are the communities. Communities is nothing but how much these 2 factors are explaining the variability. So only 0.49 out of 100, only 49% are being explained by these 2 factors for this. Okay, so this is termed as communities. Now you can see in this particular factor loadings that if here you can see that what is you can observing that these quantities. So if I will be just try to make a chart of this factor loadings. Okay, so what I'm trying to say is that if this is my f1, okay, and if this is my f2, okay, now what I'm trying to do is that this is my 0.2, 0.4, 0.6, and 0.8, and here again 0.2, 0.4, and 0.6. Now this 0.553 and 0.429. So 0.553 and 0.429. So first Gaelic will come here, and similarly 0.568, 0.288, 0.568 and 0.288, it will come something here, and then 0.392 and 0.450. So 0.3 will be somewhere here, and 0.450 it will be, okay, and then 0.740 it will be somewhere here, and minus 273. So if here it is minus 0.2, minus 0.4. So So last three factors, it will be sitting something like this. So now you can see that from this, you can see that you can say that these three factors, these top three, Gaelic, English, and history, they are very much close to each other. And similarly, these three factors, what? Arithmetic, algebra, and geometry, they are very much close to each other. So obviously, these three will be because of factor F1, and these three will be because of factor F2. And what is this factor F1? Now, the expert have to say, what is this hidden factor? So he will say that it is his verbal ability. And what is this factor 2? It is his numeric ability. So now you can see with the help of that matrix how this factors are being find out. Now, what further analysis that can be done with this is that if you rotate this axis, by if you are going to rotate this axis by theta, okay, you are going to rotate this axis by theta. Just a minute. Sorry. Okay, if you are going to rotate this axis by theta, no, what? Just a minute. Now, what I'm trying to say, if you rotate this axis by, say, angle theta, okay, now you can see that what, so this rotation is actually termed as oblique rotation. OB, oblique rotation. Now, if you'll rotate it by like this, so what will happen? This is termed as factor rotation, and because of this, now you can see that these factors are the values of these factors will be somewhat change, and you can find out that this is far better than the values of these three are more than these results. If you'll compare to the previous one, you can see that 0.553 and 0.429, they are very much close to each other. 0.39 to 0.450, they are very much close to each other. So it is very much difficult to distinguish that whether this is factor loading, on which factor it is loading more. But when you do the rotation here, estimated rotated factor loading, so here you can say that this is somewhat better than, and here it is contributing very low. So these three are definitely different factors. Okay, so this is actually termed as orthogonal rotation, and there is also the term which is also termed as oblique rotation, in which we are not going to do the. So in SPSS you will find it with the help of varimax rotation, equimax, and quatermax. All these are under the orthogonal rotation. But if the rotation is not of 90 degree, so it is termed as oblique rotation. Okay, so now with this I have already shared a data set with you, and I will be explaining it with the SPSS software, the factor analysis now, whatever the terms which are being there. So first of all, I will be explaining the data set and then how to do that into the SPSS. So this data set I've already shared into the chat box. Okay, just if somebody is difficult to find, I'm again going to share these data set into the chat box, data 1 and data 2. Click here to retry. I think I've opened it, that's why it is not sharing. Just a minute. Yes. Now, so now what it is a data of women track records. If I open the data, it will be something like this. On the first column, you can see the name of the countries are there. And then this X1, X2, X3, X4, X5, X6, and X7. Now, what are these X1, X2, X4, X5, X7? That is, you see this. So this X1 is actually the 100-meter race and how much time in second they are taking. Okay. Similarly, this X2 is time taken for 200-meter race in seconds. X3 is time taken for 400-meter in seconds. And X4 is time taken for 800-meter in minute. And X5 is time taken for 1500-meter in minute. Similarly, X6 is time taken for 3000-meter in minute. And X7 is time taken for marathon in minute. Okay. So, if I again show you the data. So for the Argentina, this 11.61 second, 22.94 second for 200-meter in second, 54.5 second for 400, and similarly 178 is minute, 9.79 is minute. For this X6 is for 3000-meter. They are, so this is the measurement of the time taken by the women of these different countries to complete the race. Now, we would like to do the factor analysis with this and exploratory factor analysis in this, and we want to see whether some factors are there or not. Okay. So for this, what I will do that I will open the SPSS. And I will call this data into the SPSS. Okay. So what I will do that I will go into the file, import data from the Excel, and Just a minute. Why this data one is not showing that I have showed to you? This data one woman. Let me check. So it's there. Data one. It's there. So it is a Microsoft Excel common CSV file. Okay. It is a CSV file. That's why it is not showing. So now what I will do, go import data, and I will go to the CSV data and drive the factor analysis data. Now it is showing the CSV file and open. Okay. So first line contains variable name. Okay. Just a minute, it will. Some problem is there. Just again. File, import data from CSV data. This open. Comma is there. Advanced text wizard. Next. Finish. Why again it is not? Okay. So what I will do right now, that I will simply copy these data set from here, and I will paste it into the, go to the data view, and here I will paste it. Okay. And then I will name it as x1, x1, x2, x3, x4, x5, x6, and x7. So this is my data set. If I'll go to the data view, this will look something like this. And now I want to see what are the factors because of which such values are coming. So for that, I should go to the analyze, and then go to dimension reduction. And in dimension reduction, this factor, I will click, and I will select all these factors, because I have to think, and then click on descriptives. I want a univariate descriptive, and I told you that I want these correlation metrics. I want KMO and Barless test. Okay. Then continue. Then extraction. How much, by which method I want to do the factor analysis. So there is principal component, maximum likelihood, principal axis factor. So I will just select principal component method. I want to display the screen plot. How I want to extract? I want to extract based on the eigenvalues. So all the eigenvalues whose are greater than 1. If I already know how many factors are, there are only 2 factors. So by this I have to put 2. But right now I'm just clicking on this based on eigenvalues, and then click continue. Then rotation. So first of all, I have just I will not do any kind of rotation. I have discussed this Varimax rotation in my slide, that if I rotate with the 90-degree, but right now I am not rotating this. I'm just first of all, and then display the loading plots. Continue. Now scores, whether I want the scores as variable. So that also can be done, but right now I'm not. And what are the options? So these are the options that how you can tackle the missing value. Okay. So with these, if I will click OK, so I'll be getting the results in the output like this. Now, what does this output is simply displaying? So the first so this first is actually the mean of this x1, x2, x3. What is x1? If you remember, this is the time taken to complete the 100 meter in second. And similarly, what is this x7? This is the time taken to complete the marathon in minutes. So the average is 173, and here the average is 11.6 seconds. For completing the 200 meter, it is 23.57 seconds. Okay, and this is the standard deviation of these factors. Now, if we'll move to the correlation matrix, you can see that most of the factors are more than 3. So it is a good data to go for the factor analysis. Okay. Now, what is this KMO test? I already told you that this KMO, if it is more than 0.90, so it is a really very good model. And Barley's test for sphericity, I already told you, in this case, the null hypothesis is that this matrix is an identity matrix. So this is rejected. Okay. So all these 2 models are suggesting that doing a factor analysis on this data is a good thing. Okay. Now communalities. So the factors, they are explaining 78% of the variability in X1. Okay. So most of them are explaining more than 70% variability, but only X5, the factors are only explaining around 56% of the variability. Now, if we'll move to the how much factors that we should consider. So this screen plot is something that you can say elbow plot. So only 2 factors you can think of considering, and rest of them are so because at this elbow you can see this is turning like this. So you can consider of taking care of the 2 factors, but here they have just gone for this 1 factor because it is turned 1 over here, and only 1 factor is there which eigenvalues is more than 1. Here you can see the eigenvalue of this factor is less than 1. Okay, so they are saying that only 1 factor is there. Now, what does we can do from here that because only 1 hidden factor is there, so this is not very great thing to do. So what I can do here, that again I will go to the analyze and go to the dimension reduction factor. and extraction, and here in extraction I will keep 2. Okay, I have changed how many factors I want to extract. So instead of going with this criteria, eigenvalues more than 1, I'm saying that I want at least 2 factors. So again, I will click continue and then click OK. So now the again descriptive statistics and correlation metrics and KMN Bartlett test, all these are explaining the same thing. But here instead of taking only 1 factor, now I am taking the 2 factors. And these 2 factors are explaining 80% of variability into the data. And if I'll go to the this screen plot, you can see that this x1, x2, and x3, they are very much close to each other. And rest x4, x5, x6, x7, they are close to each other. So obviously, this x1, x2, x3, and there are 2 factors which are playing a role over here. And now you can think of what are these factors which are distinguishing between these 2. So if you remember, this x1, x2, x3, they are very fast speeding kind of thing. Means x1 is 100 meter, x2 is 200 meter, and x3 is 400 meter. So these 3 are something which are very fast running skill. Okay, so the players who are of very fast running, so because of that the marks are coming like this. But this x6, x7, x4, they are long running skills. Okay, because they are 800 meter, 1500 meter, 3000 meter, and marathon. So these are wrong running skills. So the marks of the players, or you can say the measurement of the players are. So you can see how beautifully these factor analysis have divided the whole set of 7 factors into these 2 hidden factors of the players. Again, now I will go to the analyze and go to the dimension reduction factors, and I will go to the rotation. Why I'm going to the rotation? Because you can see that these are very much, if I'll go to the Varimax rotation, okay, and I will continue, then click OK. So this will now show me this Varimax rotation like this. Okay, so you can see that these component x1, x2, x3 are now sitting over here, and these factors are sitting over here, and this communities, this is 8.841, 0.862, 0.815. These factor loadings of the rotated are this, and for this 0.6, again this is 0.617, 0.229, 0.492, and 0.469. So these are very much close to each other. So you can see that these are the results when you have rotated it by Varimax. Again, if you are not satisfied with that, you can just look at other rotation. But there is, I told you, one is the this oblique rotation. And if you click continue and then click OK, so this oblique rotation is not equal to 90 degrees. So you can see that now this are very much close to here, and so the factor loadings will be different as you are going to do the different kind of rotation. Okay. Similarly, if you can see the another data set which are here, data 2. Okay, so this data 2 is something which is explaining about these factors. So one is our outgoing, social, hardworking, dutiful, warm-hearted, and helpful. What actually the meaning of this data set? So what is the research question for doing the factor analysis? A possible research question might be, can different personality traits such as outgoing, curious, sociable, or helpful be grouped into personality types such as conscientiousness, extravagant, and agreeable? Okay, so can these variables can be converted into these things? Okay, so these are the measurable quantity with the help of some Likert scale. Okay, so how it can be done? So again, I will go to the file, import data set from the Excel, and this is data 2. I will open it. Okay. Okay. Now this is the most important thing about doing the factor analysis, is that your data should be on the scale, or it can go to the ordinal, but it should be on the scale. It should be numeric. It should be of scale, because calculating the mean, you can see that we are doing all the calculation with the help of the mean and the variance, and mean and variance are valid for only scale data set. So that is one thing we should be taken care of. And again, going to the factor, and I will select all these variables, and again I will click descriptive. Okay, KMO and Bartlett test, and coefficient, continue, extraction, unrotated factor solution, principal component, and again based on the eigenvalues I will select this. Then for the rotation, I first of all I will do not do any kind of rotation. I will select loading plots. Scores, okay, I will not save the scores, and then in option, so continue. Now again I will click OK. So for this data set, this is the mean of these variables which are under consideration. You can see that in correlation metrics, some of them are 0.583, less than 3, and you can see that many of them are less than 3. So because of this also, you can see that this KMO test, it is not less than 0.50. And also the Bartlett-Spaghetti test is very much close to the significance level. So I can say that this data is not very much good for doing the factor analysis because of these results. But still, if you want to do, you can proceed with. But the statistics suggest that this is not good. The reason may be because of the less sample size. We have only 20 observations. Okay. Now, if we'll go to the this component matrix, so you can see that how these there are 3 components. There are 3 factors which are being there. The first factor is actually have high marks with outing and social. The second factor have more marks, 0.793, 0.659 for a hardworking and dutiful. And the third factor have more marks with this, you can say, more factor loading with this warm-hearted and helpful. Okay, so clearly this indicates that all these observable quantities can be reduced to the 3 components. Okay, and this is a 3-dimensional plot: component 1, component 3. So this social and outgoing are close to each other, hardworking and dutiful are close to each other, and helpful and warm-hearted are close to each other. And you can see also in this diagram that this outgoing and sociable are extraversion trait of the person, hardworking and dutiful is his consistency, and warm-hearted and helpful is his agreeableness. Okay, so that is what from my side. Now the session is open for question and answer.
Sir, for the first one, the problem that you have shared, what would be the research question? Like here, we are grouping the things. What would be the research question for the first problem?
The research question is that you can see that this is the data set which I was dealing with, and you want to see that whether the speed or whether these records are something is a hidden factor because of which such values are coming. Okay, you can see from the results that in result x1, x2, x3 they are very much close to each other. So these three factors are associated with speed of the ladies, and rest these are associated with endurance of the woman. Because this is the data on the women track records, how much time they are taking in Argentina, Australia, Austria, India, Belgium, all these are countries, and how much this is the record of the women in these countries. So the question is that whether these track records are coming, what are the inherent, what are the hidden characteristics because of which such records are coming. Okay, so this is the idea, and we have found out that this x1, x2, x3 are contributing the speed of the woman, and x4, x5, x6, x7 are contributing the endurance of the woman track records. So that is what, and this is the exploratory factor analysis. We are exploring that what are the hidden factors. So the PI or the that person is very much he should answer that, because in the results you can see I'm simply getting the results like this. Okay, here I am getting the results like this. The first result which I got, it is the result. So it is simply saying x1, x2, x3 are close to each other, and these factors are close to each other. Now it is the duty of the investigator to find out why these x1, x2, x3 are very much close to each other, because of some hidden factor. What is the name of that hidden factor that he have to decide, because that is actually the unmeasurable quantity because of which such parts are coming out like this.
Okay, that is, it is establishing an association between, means kind of, if these factors are
It is doing
closely
two
related.
things, man. It is, first of all, it is reducing the dimension.
Yes.
Out of these 7, it is reducing the dimension to the 2 dimension. Okay, and another thing it is doing, that it is finding out 2 factors. So one factor I am just named speed of the woman track record. This is the speed, how much speed they can do, and this is the endurance. Endurance is very difficult to measure, so these factors will measure the endurance of the woman.
Yeah.
So this
Thank
is this means
Thank you,
this is a hypothesis of the PI.
No, sir. This is he explored and he find out that x1, x2, x3 are very much close to each other.
The
Now,
unmeasurable things, no, that you have to find out what is common to them.
that is that. Now, what are the things because of which x1, x2, x3 are very much close to each other? So just I named it because these 3 are associated with the very fast running, because they have to run very fast to 100 meter, 200 meter, 400 meter. Okay, but rest are endurance, means the who can run fast, not only, and who can run fast up to a very long time. So that's why this is another trait. They are coming close to each other.
So what?
Yes.
So what should be the Bartlett sphericity value, and when do we go for rotation?
You can see that when these things are very much close to you, when you can see that here these the difference between these two are not for example here 753,478, 839. So in this case there is no need to go for this rotation, because it is clearly indicating that these 3 are negative, and these three are positive, but the difference between these are quite large. So there is no need for going for this rotation. And here also in the screen plot also you can see that they are very much close to each other. In such case, there is no need to go for the rotation. I just illustrated what will happen if you will go for the rotation. Okay, I just illustrated. You can see if I go for this very max rotation, so the values, all things are coming positive now. This will come something like this, around in the range of 8, and all these will come around in the range. Now you can see, you cannot distinguish between X4. Okay, X4 is what? X4 is 800 meter. So it will come in both. Okay, speed may be aa raha hai, it is coming in the speed also, it is coming into the endurance also. Got it?
So excuse me, sir. So it is the same group of people you were taking to that like 100-meter short run and high distance run. So it's automatically. My question is that it is the same group of people like you have
Yes,
taken this
yes. It is,
different countries. It is the
yes.
same group of
No,
people
ma'am.
you have taken.
This is the track record of the Argentina women. How much? What is the track record of these 7 kind of events? What is the track record in Australia? What is the track record in Austria? Okay, this is something like,
But
so you
country,
can,
country versus country, it is not like that. It is.
no. This is something that these are the factors I told you in my slide that these are the observable quantities. With the help of these observable quantity, I want to identify unobservable quantities. So there are 2 unobservable quantity, F1 and F2. F1 is the speed endurance of the woman. F1 is the speed of the woman track record, and F2 is the endurance of the woman track record. Okay.
So
that is
one
what-
more doubt here. When
Yes.
grouping these means these factors, X5 seems to be a outlier, like, but it is at 1500 meter. So
No,
how
this
it
is
will
not,
be explained on the basis of any 2 factors or any 2 things that are contributing to it?
how you can say this X5 is the outlier. I am
Means not exactly an outlier, sir, but it is not grouping in with X1, X2, X3, and neither with X4, X6, and X7.
No, that is what you can see here. Here you can see that this, no, this, if in the previous rotation you can say this, yes, this X5
Yeah.
is not, yes, you are correct that this X5 is not going to associate with this X1, X2, X3, X4, X. You can also think of that how much distance you can. That's why I did the factor rotation. Okay, in the factor rotation again, it is again at a very far distance. Then I did the oblique rotation also into that, and in the oblique
Again, it
rotation
is far.
it moves to a bit more far away. So
Yeah.
yes, you can say that this X5 is something different factor. What is the name of that factor? That you have to decide.
That
The-
has to be decided. Okay.
Yes.
Sir,
So it is
sir,
not
can
an
it be
Means just
combination
for
of both?
speed and endurance.
Yes, you can
cannot
say
tear it apart.
that it is a measurement of speed. Can be speed and endurance. But again,
Combination of both.
yeah,
like that?
again, you can say that this X4 is 800 meter, so it is also speed and endurance kind of thing. Okay. Now this data is something like this. The results are coming out like this. So explaining these things in the paper is become quite tricky. So at this particular point in time, statistics is saying this. Now you have to interpret why such results is coming. What are the factors because of which such result is coming? That is the beauty of factor analysis.
Thank you.
Okay.
Sir, what is the significance of taking eigenvalue greater than 1?
I'm not saying that this is the, because you can see that this is one of the thing that because of which it is explaining more percentage. If the eigenvalues is high, if it is more than 1, it means this factor is going to explain more. You can see that the eigenvalues is 0.5, so the percent it is explaining 72. If the eigenvalue is around 0.6, less than 1, so only 8%. If it is more than 1, so the percentage which is explained by the eigenvalue is somewhat higher. But if it is less than 1, the percentage which is explained by it is somewhat lower. So that's why usually it is said that if the eigenvalues is more than 1, so it will be good to take that factor into account.
Thank you, sir. Sir, one more question. Sir, can you tell me the significance of rotation, very mixed rotation and oblique rotation?
I told you na that sometime what happen when you can see that distinguish between these two factors just 0.449, 0.551. So if we rotate it and clearly identify that these three are together and these three are not together, so at that particular point of time we rotate it. I also tell you in my slides that when we rotated it by 90 degree, the difference between the components are quite clear. So that's why we do this varimax rotation.
Fine.
Sir, reducing the number of factors is decided by us. Is it, sir?
Reducing the number of factors is, I told you that there are three ways. One way is just go for this screen plot and see where the elbow is there. Another is see the how this the eigen value if it is more than one. So by this up to which factor we should go. This is the way by how we can decide how much factor we should retain.
So we can take more than two factors also.
Yes, there are three ways by which we can decide. One is that up to what percentage of variability we would like to explain. If we would like to explain up to 90%, so in this case we should go up to 4 components. Okay, we want to explain 95% variability of the data. So for this we need to go up to the 4 factors. Okay, so that is one criteria. Another criteria is this how much that this now another criteria is this more than one. Our third criteria is the screen plot. So these 3 criteria are there by which we decide how many factors we should retain. Before doing the factor analysis, if you say that I want 90% of the variability explained, so for this you should go up to 4 factors. But you say no, only I will take those factors for which the eigen vector is more than 1, eigen value is more than 1. So in this case, you have to go with only 1 factor. Okay, but the screen plot is saying that elbow is taking up care of the 2 factors. So you say that no, I should go with the 2 factors. So there are different criterias, and you can proceed with any one of these.
So one more thing, without rotation, when the plot was constructed, it was written as component plot, and the axes were like component 1 and component 2. So what does this component 1 and component 2 exactly mean?
This is the factor 1 and this is the factor 2.
Okay.
This is nothing but you can see that this is the value and this is plotted over here.
Yeah.
This is the biplot of this. These are the factor loadings that lambda 1, lambda 1, 2. That was I was explaining now.
Yes,
this
yes.
is the same values and this is biplotted over here.
Okay. Okay. And these factor 1 and factor 2 that investigator has to decide.
Yes.
Okay.
Excuse me, sir.
Yes.
While importing data in SPSS
yes.
factor analysis, can you once again tell us the important steps how we should proceed? Because I saw you clicked many this analysis part of means what we want to means those things is little confusing. So can you once important steps which are compulsory to be clicked?
Go to the file.
Yeah.
And open. Okay. And then in open, go to the data. Now you have to decide what is your type of data. Whether your data is already in the SPSS format, or your data is in the form of the Excel, or your data is form of the CSV or text, or your data is in the form of Stata. What kind of your data is? If your data is in the form of the Excel, click on Excel. And then by clicking over here, go to that particular folder in which you have kept your data. And then select that data and then click open. When you click open, it will show, the window will show you like this. If you'll see the preview of the data over here, if you see everything is fine, just click OK. So your data will be loaded.
So regarding the factor analysis part.
Yes. Factor analysis.
After
So
this, yeah,
again, you go to the analyze and then go to the dimension reduction and go to the factor. Select all these data over here. Okay.
From this step onward, yeah. Now these steps actually I wanted. Yeah.
Then go to the descriptive and univariate descriptive. Then for correlation matrix, I told you have to select this.
For how to decide this? Which one means only coefficient?
Only these two. I told you, na.
Okay.
By this you have to decide if all the values are more than 0.3. It means it is good for doing the factor analysis. Okay. If KMO test, I told you that if values are more than 0.9, it is a very good thing to do the factor analysis. If the Barless test of asperities is coming significant, it is good to do the factor analysis. This is a primarily test. If these values are not coming good, you should not proceed further for explaining the factor analysis because the data is not good for doing the factor analysis. Then click continue and then extraction. Extraction, you can see by which method you want to extract. So just select principal component method and then select the screen plot. By which method you want to explain? So based on eigenvalue is greater than 1, or you want fixed number of factors, and you want at least 2 or 3 number of factors. So first of all, just click on this, then click continue. Then rotation, you want to rotate the axis by 90 degree, or you do not want any kind of rotation, and then click on the loading plots. Continue. And then in scores you have to do nothing, and in options you have to do nothing, and just click OK. Okay. So by this the results will come.
Thank you very much.
Sir, we are running late, so can we wind up the session?
Yes.
Okay. So participants, if you have any queries, you can write directly Dr. Anu. Service with BS in the so you have email ID. So okay, so I think most of the things are covered.
In the chat box, please share the email.
Yeah, so please share your email in the chat box.
Okay. So what I hope this session is helpful for you, and thanks a lot for giving the opportunity to share my ideas on the factor analysis.
Thank you, sir. Thank you so much, sir, for your valuable session. And thank you all. Thanks to all the participants.